Today I'll be talking about the research we've done the past nearly 2 years about using AI to understand privacy policies and to make the privacy experience more usable to the actual users. I've done this work in collaboration with Hamza from EPFL and Tom, who joined my group this year in the University of Wisconsin-Madison. So when we talk about privacy notice and choice, we're mostly referring to the FIPS guidance on privacy. And every company you're supposed to be interacting with have to provide you with a privacy notice. They have to tell you how they're collecting your information, how they're processing it, where they're storing it, and with whom they are sharing it. And if you've used the internet for long enough, you'll know that most of these privacy notices come in the form of privacy policies. These long documents that most of us don't actually read. But when we're actually using the website, we're agreeing to this privacy policy, which is somehow a binding agreement now between us and the service providers. And the main problem that we're addressing in our research is that these privacy policies are too long and too complicated. Just to give you some idea about how long they are. So a Wall Street Journal earlier this year did a study on the top 30 used apps, and she printed out the privacy policies. And they spanned a whole football field. In 2008, there was a study by McDonald and Craner from CMU where they actually counted the number of hours you have to spend reading the privacy policy of every website you interact with. They estimated that it will take you around 200 hours per year to read all of the privacy policies you interact with. Remember, this was in 2008. So this was before the mobile and before the Internet of Things, right? So now just count how many websites you browse, how many apps do you use, and how many smart products do you use. And all of those are associated with privacy policies. I don't read them, although I do research in the area. I'm not sure if any of you actually take the time to read those privacy policies. And they sometimes do contain lots of information. So every time there's like some controversy in the news, like this company is doing A and this company is doing B, if you dig deeper in the privacy policy, they actually don't say we're not doing this, but they just hide it in very long and complicated privacy policies. Of course, we're not the first to identify that this is a problem. Researchers of the past 1 or 2 decades have been looking into mechanisms to make these privacy policies more reachable to the users. One such approach is the nutrition labels approach, by which you have the provider summarizing their privacy policy in the form of a nutrition label. Like, for example, ways they collect information for each type of information, and then you have the options for the users. This has the advantage, it's actually the privacy policy or the privacy practices are visualized. This provides you with a standardized way to compare privacy practices across different companies and websites. But the main disadvantage is that you require the providers or the lawyers to actually code the privacy policy in such a format. And surprise, or actually, I'm not sure if it's a surprise, nobody really acted on this. It's a very nice, very cute research proposal, but that never got deployed in practice. A second approach was, well, if providers are not willing to do it, how about we crowdsource it? And there was this service online a few years ago, TOSDR, Terms of Service Don't Read. And then they relied on volunteers to actually read privacy policies and then describe them in few informative sentences. So for example, this is the privacy policy of Google. They will say those are the positive privacy practices, those are the negative privacy practices, and then they're gonna assign it a score. Obviously, A is a good score, and then as you go down in the alphabet, the score gets worse. The main problem is it's limited by the volunteers' availability. So you need actual people to go look at those privacy policies, analyze them, describe them, and then you're limited. Well, how many people are going to do that? You have lots of privacy policies, and those privacy policies change over time. So every time Google changes its privacy policy, somebody has to go there and read it and do that again. And this is actually a big problem in the privacy policy space. So it's very important to provide this information to users in an intuitive way and in an understandable way, but the breadth and depth of privacy policy makes it a little bit challenging to rely only on manual efforts. And that was before we had emerging technologies. Let's look, for example, at newer devices that have UI limitations. Smartwatches, vehicles, smart speakers, and voice-only devices. Now, for those devices, even if you want to summarize the privacy policy, even if you want to provide a nutrition label kind of format, even if you want to provide some summary in forms of sentences, those devices are UI limited. So you can't just provide them in the old way. So you have to rethink how to provide users with privacy notice and choice for these kinds of devices. Now, one way we envision it is to have some sort of a conversation, like users asking questions and then a system automatically getting the answers from privacy policy. And we refer to this scenario as unstructured queries, or unstructured queries to a privacy policy, where the query is basically a natural language question. GDPR, who's the star of today's hackathon, actually have come up with an interesting challenge. We have lots of policies, and then you might need to do regulation compliance on a scale. For example, if you need to understand the privacy policies that are addressing health information, you need a scalable way by which you can query the policy by saying, well, for this policy, get me all the segments that describe third-party sharing with the personal information type being health information. And because we have like key value pairs in this query, we refer to this type as structured queries. For this talk, I'll be talking about two components. I'll be talking about the automated system that allows us to reason about the privacy policies, which we call policies. And I'm going to present GDPR compliance as one possible application that relies on structured queries. So bear with me a little bit. So our solution is policies, which is a unified framework for privacy policy analysis, such the name, policy analysis. And it supports, as I said, two types of queries. I'm going to be focusing on the structured queries, and you can visit our website, pribot.org, which gives you an overview of the technology, and you can actually use our chatbot that allows you to ask questions about privacy policies and visualize the privacy practices of different companies. Okay. We have to make things sophisticated, so this is why you have this block diagram. But at the core of it, it's not magic, actually. So there's basically three main components. We have what we call an application layer, which allows the user to interact with our system. The user can basically pose queries, and then they just have to indicate the privacy policy link. Or actually, they have to only provide the URL of the company they're interested in. We automatically fetch the privacy policy link. Now, the privacy policy link will go to what we call the data layer, which is basically a headless browser that goes to that link, fetches the privacy policy, and segments it. Segmentation requires breaking the privacy policy into segments, or into paragraphs. Okay? Then these paragraphs pass into what we call the ML layer, which just makes the privacy policy machine readable. Machine readable means that each paragraph is going to get privacy categories and annotations. And I'm going to describe those. Okay, so we're just going to label these paragraphs by the privacy practices that they are describing. And that's going to become clearer in a second. And then once the privacy policy is annotated, and depending on the user's query, we do some comparisons, and then we get the user's result back. And those will be clearer in just a second. So this is a high-level overview of our policy segmenter. Suffices to say, as I said, we get the HTML, we break it into paragraphs, and those paragraphs, we consider them as the building block of a policy. So a policy is basically defined as a sequence of paragraphs. That's it. Okay? So that describes the data layer. The more interesting component of our policies framework is what we call the segment classifier, or the segment classifier, which takes, as I said, a segment and then extracts the privacy practices embedded in it. And this is an example from Intel's privacy policy. So this segment of the privacy policy of Intel describes the data retention practices. Okay? So when we want to annotate or when we want to automatically label these privacy policies or these segments, we focus on two levels of labeling. The first level is what we call high-level privacy categories. On a high level, this paragraph or this segment is describing data retention. Then we go a bit deeper into the privacy policy segment, and then we start extracting attributes. for example, the information type described in this segment is generic, because your information doesn't specify what type of information. And the purpose of the data retention is legal. So this purpose is legal requirement. Now, a natural question is, where do these high-level categories and values and attributes coming from? And they are coming from a privacy taxonomy that has been developed in CMU in 2016. So as part of their reusable privacy project, they recruited law students from Fordham Law School in New York, and then they gave them 115 policies and asked them, well, please label these privacy policies or sentences in these privacy policies according to the following privacy policy taxonomy. And that resulted in 23,000 human annotated or expert annotated privacy policies. And for those of you who are active in machine learning, this is like actually a trove. Now you have labeled data that you can use to train classifiers. And on a high level, this taxonomy has two levels. The high level one is the privacy categories. First party collection, how the service provider is collecting your data, for example. Third party sharing, with whom they are sharing this information. Whether this access, edit, or delete, basically the privacy choices provided to the users, data retention, security. So those are the high-level categories we use to describe segments. And then we have lower-level attributes that can assume different values. For example, a collection mode describes how the first party is collecting your data, and this is an attribute that can have different values. For example, a value could be collect on website, collect from external website, collect from mobile app, or it could be unspecified. We don't know, we don't have a specific value for that attribute. Or information type, for example, which could be financial, health, contact, location, and could also be unspecified. So we use this taxonomy. We use these labels that have been annotated by experts and from law school experts to train our classifiers. And because this data by nature is hierarchical, so we train our classifiers to be hierarchical as well. So basically, we have a category level classifier, which is a multi-label or multi-class classifier that gives you the different privacy practices embedded in a certain paragraph. And then we have, for each attribute in that taxonomy, we have a specific classifier that gets us the values associated with that attribute, okay? And that resulted, I remember, with like 22 classifiers or so, and just 21 classifiers. And if you're interested, our classifiers are basically simple CNNs. So there's a word embeddings layer, and then you get the class's probability, so just from a high level. And you have trained our embeddings on a corpus of privacy policies that we collected. Embeddings, I should have explained embeddings. So neural networks or classifiers take numeric inputs, right? And your privacy policy are text. So word embeddings are just a way to translate words into vectors of numbers. That's it. And you can and there are mechanisms, well-known mechanisms that describe how you can extract those. So this takes care of our segment classifier. So at this point, we have the privacy policy. We have broken it into several segments or sequence of segments, and each segment has been automatically annotated by a high-level privacy category or several high-level privacy categories, and then key value pairs, which describe the values of each attribute in that taxonomy. Once we have the privacy policy now machine readable, we can query those labels. And one example of querying those labels is GDPR compliance, which I'm going to be describing in the second part of my talk. So just a reminder of what we call structured queries. So those are first-order logical clauses on those labels of the privacy policies, and that's going to be clearer in a little bit. Okay, so for example, as I described before, one structured query could be, if you're aware of SQL or several structured queries, so select all segments such that, or where, category equal this much and purpose equal advertising. So those are basically the queries that our system allows us to do. Okay, and those are basically attributes that are associated with each segment. So basically, it's just like a very simple querying. You can look at the annotated database as annotated privacy policy as a big database or a big table that has the segments, and each segment has attributes, And each attribute is the probability associated with each category and each attribute key value. Okay? I think most of you know what GDPR is. Just I needed to put a slide on GDPR, so that's the GDPR slide. So it's the General Data Protection Regulation that has been approved in the EU in 2016 and has been enforced in May 2018. And one of the most important attributes of this law that it has teeth, meaning that they have two levels of penalty. The high-level penalty says a company can be liable to up to the maximum of 20 million euros or 4% of the worldwide annual revenue. Think Google, Twitter, and Facebook when you say like 4% of worldwide annual revenue. So that's a lot of money. And they are liable for paying these penalties if they infringe on the basic principles of processing, consent, and the data subject's rights under Articles 12 to 22. And if you've read the text of the GDPR, those are the aspects that should be typically embedded or described in a privacy policy. The right to be informed, the right to be informed about changes in privacy policies, the right to be forgotten, the right to have choices, and these kinds of things. And these two facts describe why in May 2018, like a few months ago, your mailboxes were flooded by changes in privacy policies. I'm not sure if you still remember that, but at some point, we got lots of emails saying, these are our new privacy practices, these are our new privacy practices. And those were obviously all motivated by the enforcement of GDPR. So a natural question with the enforcement of GDPR, how did GDPR change the landscape of privacy policies? And we looked into 5 different criteria. How did they change in terms of presentation, accessibility to the users in reading, coverage of privacy practices, ambiguity in describing the privacy practices, and compliance with GDPR. And our approach was to get a corpus of privacy policies, get their pre-GDPR version, and compare them to their post-GDPR version to see how things have changed in the meantime. Not to bore you with the details, but we had an interesting pipeline by which we get the policy, we get the URL of the company, and then we dig up its privacy policy link, and then we can analyze it. We have analyzed websites from Alexa top categories list. So Alexa is a company that's owned by Google that provides ranking of top visited websites. I'm sure you know the top 1 million visited website from Alexa. Another ranking they have is by category. So they have defined like 25 categories. And for each category, you can get categories like health or news or whatever, or regional. And these categories, you can get the top 500 visited websites. So we thought those have a good balance and good breadth and good diversity of websites that we can actually analyze. We got their privacy policy links. Then we went to the Wayback Machine to get their pre-GDPR version from July 2017. And at the end of the pipeline, because of lots of complexities and rate limiting here, we ended up with analyzing 386 unique privacy policies for which we had the pre- and post-GDPR versions, meaning the entire HTML. First, we focused on analyzing the presentation. We analyzed the change in HTML tags between pre- and post-GDPR. We have noticed with statistical significance that the post-GDPR privacy policies actually use more structural and style HTML tags, which means that they are trying to organize their content better. Like think HTML tags, think about labels, images, lists, bullet lists, these kinds of things. Style, think about bold, italic, font colors. And those have been used more in post-GDPR privacy policies. For those of you who are know a little bit more about the HTML processing, when we analyzed the privacy policy, we isolated it from everything else on the website. So those are not influenced by the banners or headers or side menus. So those are already been removed. So this is just the privacy policy HTML. We also performed a privacy user study by which we provided users with snapshots of pre- and post-GDPR. Users didn't know which is which. They just saw snapshots, and we asked them to answer a few questions, whether they find this to be attractive, clean presentation, or positive experience. Surprisingly, we didn't find any significance between the pre- and post-GDPR privacy policies. So users ranked them the same, and that warrants more investigation, actually. Then we studied the readability. We focused mainly on how long the privacy policies have become and on other readability metrics. The main takeaway is that privacy policies are significantly longer now. So if they took a football field early in 2018, now they will take more. So they use significantly more words and significantly more sentences to actually describe the privacy policies, and that's understandable because they have to actually address more privacy practices. For the last three criteria for our analysis, coverage, ambiguity, and compliance, we relied on output from policies to understand the privacy practices of these pre- and post-GDPR. We looked into the coverage, how many of those high-level categories of privacy policies have been described, and then we can look like, okay, how many policies do describe first party? How many policies do describe third party? And we show them on this graph. So this is the percentage of policies pre- and post-GDPR. And as you can see, for several privacy criteria or categories, there's more coverage from the post-GDPR. And mainly you can see that from data retention, data security, and then third-party sharing, where you can see statistical significance for increase of coverage in describing privacy practices from pre to post-GDPR. We also looked at the ambiguity, how specific a privacy policy is in describing a certain privacy practice. And for that, we looked at the policies output that says unspecified. Like there's a purpose, for example, in this case, but it's unspecified. We defined 10 ambiguity or 8 ambiguity queries by which, like, an example, is the privacy policy specific about how the first party is obtaining user data? And as you can expect, we got a mixed bag of results in describing ambiguity. Some of the policies still do not cover some of those practices described here. Some of them still do not have any ambiguity, which is good. Many of them have actually improved in terms of ambiguity, and some of them have been worsened in terms of ambiguity. And we have examples in our paper, which I have a link for, why there have been worsened in terms of ambiguity. So in an effort to meet the rules of a GDPR, they have been more verbose and more generic in describing their privacy practices. And finally, we performed analysis in terms of coverage, how many categories or how many privacy practices these privacy policies are in compliance. And this is an example actually of our filtering or first order logic that happens or that we ran over GDPR. GDPR influenced filtering logic that we ran on the output of policies. And just an example, let's say that, and those are the checklist items we got from the ICO, the Information Commissioner's Office from the UK, which describe the GDPR clauses. Just an example, like the policy should describe the purposes of processing users' data. So our query in such a case would be, select the set of segments in the policy, which have a category equal first party, and the purposes does not equal unspecified. Okay? And then the score is the number of the segments. And then we compare, in this case, the number of segments that satisfied these queries before and after GDPR. So this is an example there. And those are the results for the compliance. So as you can see, as you might expect, for some of those queries, some of those clauses in GDPR, they are still uncovered. Some of them, they are still covered. Some of them have worsened, and some of them have improved. And the next few slides, I'm going to show you quickly some examples from these privacy policies, just to make things more interesting. So this is a privacy policy from Trulia. And this is an example where requirements are still missing. So we're talking about data retention. And this is the data retention clause from pre-GDPR, from post-GDPR, and still they do not specify a retention period. Okay, so this will be into the category of still missing, for example. Example where things have actually worsened is a clause from the McKinsey's privacy policy where they had a data retention period over here in the pre-GDPR segments. If post-GDPR, they do not have any data retention period. So it's unspecified, which means it's not covered anymore. Examples where things have improved is with New York Times privacy policy that now describes privacy policy change clauses. So a privacy policy have to tell you how do they notify you about changes in privacy practices. New York Times didn't have any clause about such a thing in their pre-GDPR. Now they do have a clause describing how they change their privacy policies and how do they inform you about it. I spent the whole time talking about privacy notices. We're also working on privacy choices. You have if you use Facebook or Twitter or social media or any platform, to change your privacy settings, you have to navigate a long and complicated list of settings menus that they are unreachable to the regular user. We're using AI to make this process easier to the users by understanding their privacy preferences and applying their privacy preferences automatically on those websites. We also have several other applications of policies, which you can see if you visit private.org. We have a tool that visualizes the privacy practices of policies. We have a tool that is a chatbot by which you can ask questions about privacy policies in your natural language, and we get answers from those privacy policies, and also allows you to see summaries of those clauses. And coming soon is a tool that allows us to score privacy policies by looking at positive and negative privacy practices. We have had this website online for nearly a year now. It has been widely used. We have licensed this technology to a browser company that we can't say. And thank you for your attention.